Hello students, welcome to experiencetutor.com. Today's we'll go to discuss electrostatics part 6. Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th, and those who are appearing for the school board examinations and entrance examinations like IIT, NEET, and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you. Question 36. Explain continuous distribution of charges. We can determine the net electric force acting on a point charge due to the discrete charges in the space using Coulomb's law and superposition principle. But in practical situation, we need to work with the continuous charge distribution. For example, a continuous charge distribution on a surface. In this situation, it is difficult to describe the effect of these charges using superposition principle. Therefore, we use the concept of charge density to describe the system to continuous charge distribution. It is not necessary that charge density will be uniform in the system. The continuous charge distribution of electric charge can be of three types. First, linear charge distribution, surface charge distribution, third, volume charge distribution. Question 37. Describe an equation for electric field at a point due to linear charge distribution. Consider a continuous charge distribution over a line as shown in the figure. We want to determine the force acting on a charge Q situated at point P due to this charge distribution. Let the amount of charge per unit length of line is lambda. It is called the linear charge density. Lambda is equal to total charge on a line upon length of a line is equal to Q upon L. Unit of lambda is coulomb per meter. If the charge distribution is not uniform, then lambda will be different at different points on the line. In that case, linear charge density is represented as lambda r at the point on the line having position vector r. Imagine the line to be divided into large number of small segments of length dl. Such a line element dl having position vector r with
respect to O as shown in the figure. dq is equal to lambda r modulus of dl. The force acting on charge q having position vector r will be df k dq dq upon r minus r whole cube, position vector r minus r whole cube. In order to calculate total force acting on charge q, we have to add the force like dF due to all the line elements of entire linear charge distribution. If the line elements of the charge are distributed continuously, then the sum results into integration. Total force F is equal to integration L dF is equal to Q dQ upon R minus R whole cube into R minus R. If F is equal to KQ, lambda R dl upon R minus R whole cube multiplied by R minus R position vector, equation 1.8.3. If the charge q situated at a point is very small, then charge q tends to 0, then intensity of electric field at that point due to linear charge distribution will be E is equal to F by Q. If we put the value, integration L lambda L dl upon R minus R dash whole cube into R minus R dash position vector. Question 38. A circle as shown in the figure have radius A, line charge distribution over its circumference have linear charge density lambda is equal to lambda cos square theta. Calculate the total electric charge residing on the circumference of the circle. The length of an infinitesimally small line element shown in the figure is a d theta. Then the charge on the linear element is dq is equal to lambda a d theta is equal to lambda naught cos square theta a d theta. In order to calculate the total charge q residing on the surface, we have to integrate delta q over the entire surface. Q is equal to integration of delta q with the symbol q is equal to 0 to 2 pi lambda 0 cos square theta a d theta is equal to a lambda 0 is taken out, integration between 0 to 2 pi cos square theta d theta is equal to pi a lambda 0. Question number 39. A conducting wire of length L carries a total charge Q with a uniformly distributed on it. Find the electric field at a point located on the axis of the wire at distance A from nearer end. Neglect the thickness of the wire. The charge in this element will be delta Q is equal to q upon L dx. Hence, magnitude of the electric field at point P will be dE is equal to k dq by x square is equal to k q by L dx by x square. Now, electric field at P due to the entire wire is E is equal to integration lower limit A upper limit L plus A dE. Kq upon L integration lower limit A upper limit L plus A dx by x square, taking out common Kq upon L minus 1 by x A L plus L plus A is equal to Kq upon L bracket 1 by L plus A plus 1 by A is equal to K q upon A bracket L plus A is equal to 1 by 4 pi epsilon naught q upon A L plus A. Note, if L is much less than A and E is equal to 1 by 4 pi epsilon naught q upon A square, which is same as electric field due to the point charge. If the charge q is positive, the direction of the field will be along AP. Question number 40. An arc of radius r suspends an angle theta at the center with the x-axis in a Cartesian coordinate system. A charge is distributed over the arc such that the linear charge density is lambda. Calculate the electric field at the origin. The electric charge distributed on the portion of arc making an angle delta phi is dq is equal to lambda r delta phi. The electric field at the origin due to this charge is dE is equal to k lambda r d phi upon r square. The electric field vector dE is shown in the figure taking two components of dE. dE x is equal to k lambda r d phi upon r square cos phi unit vector I, and dE is equal to dEy is equal to k lambda r d phi upon r square sine phi unit vector j. This whole equation is with minus sign. Now Ex is equal to integration from 0 to theta dEx is equal to minus k lambda upon r integration 0 to theta cos phi d phi unit vector I is equal to minus k lambda upon r sine phi 0 to theta I. Therefore, Ex is equal to minus k lambda upon r sine theta unit vector I. Now Ey is equal to minus k lambda upon r integration 0 to theta sine phi d phi j is equal to minus k lambda upon r minus cos phi 0 to theta j. Ey is equal to minus k lambda upon r cos theta minus 1 j. E is equal to Ex plus Ey is equal to minus k lambda upon r sin theta I plus k lambda upon r cos theta minus 1 j. From equation first and second, E is equal to k lambda upon r minus sin theta I plus cos theta minus 1 j. Question 41. A charge q is uniformly distributed on a circumference of a circular ring. A charge q is uniformly distributed on a circumference of a circular ring of radius a. Find the intensity of charge field at the point at a distance x from the center of the axis of the ring. Given situation is depicted in the figure. Given situation is given in the figure. Consider an infinitesimal element of point A on the circumference of the ring. Let charge on this element be dq. The magnitude of the intensity of electric field dE at a point P situated at a distance x from the center of the axis is dE is equal to 1 by 4 pi epsilon naught dq upon ap square is equal to k dq upon a square plus x square. The direction of a to p. Now consider two components of dE. First, dE sin theta perpendicular to the axis of the ring, and second, dE cos theta parallel to the axis. Here it is clear that in the vector sum of intensities due to all such elements taken all over the circumference, the dE sin theta component of the diametrically opposite elements will meet each other as they are manually opposed. Hence, only dE cos theta component will only should be considered for integration. The total intensity of electric field at point P E is equal to integration dE cos theta is equal to integration k dq upon a square plus x square op upon oa. Cos theta is equal to op upon ap. E is equal to k dq a square plus x square root. Therefore, E is equal to kx upon a square plus x square 3 by 2 integration surface dq kxq upon a square plus x square 3 by 2 a 1 by 4 pi epsilon naught xq upon a square plus x square 3 by 2.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.